Vaishnavi, Assistant Professor, IT Department from SNS College of Engineering. Now we are going to see about the deadlock in operating systems. Deadlock, a process requests resources. If the resources are not available at the time, the process enters the wait state. Waiting processes may never change the state again because the resources they have requested are held by other waiting processes. This situation is called the deadlock. A process must request a resource before using it and must release resource after using it. First one, request. If the request cannot be granted immediately, then the requesting process must wait until it can acquire the resources. Second one, use. The process can operate on the resources. Third one, release. The process releases the resources. Deadlock characterization. Four necessary conditions for the deadlock. First one, mutual exclusion. Second one, hold and wait. Third one, no presumption. Fourth one, circular wait. First one, mutual exclusion. At least one resource must be held in the non-shareable mode. That is, only one process at a time can use the resources. If another process requests the resources, the requesting process must be delayed until the resource has been released. Second characterization is hold and wait. A process must be holding at least one resources and waiting to acquire the additional resources that are currently being held by other processes. Third one, no presumption. Resources cannot be presumpted. Fourth one, circular wait. The process P0 is waiting for the resources that is held by the process 1, and process 1 is waiting for the resources that is held by the process 2. Next one, methods for handling the deadlocks. We have four methods. First one, deadlock prevention, deadlock avoidance, deadlock reduction and deadlock recovery. First one, deadlock prevention. Deadlock prevention is the set of methods for ensuring that at least one of the necessary conditions cannot hold. Second point, by ensuring that at least one of these conditions cannot hold, we can prevent the occurrence of the deadlock by denying the mutual exclusions, denying the hold and wait, denying the no presumption, denying the circular wait. Next one, deadlock avoidance. Deadlock avoidance requests that the OS be given in the advance additional information concerning which resources the process will request and use during its lifetime. Second point, with this information, it can be decided for each request whether or not the process should wait. Third one, to decide whether the current request can be satisfied or must be delayed. The system must consider the resources currently available, the resources currently allocated to each process and future requests and releases of each processes. Next one, here we have the diagrammatic representation. First one, deadlock. If deadlock occurs, that condition is the unsafe conditions. Next one, two algorithms are used for deadlock avoidance, that is resource allocation graph algorithm and bankers algorithm. Resource allocation graph algorithm, that is single instance of the resource type. Next algorithm is bankers algorithm, that is several instances of the resource type. Next one, deadlock deduction. Single instant of the resource, each resource type, that if all the resources have only a single instance, then we can define the deadlock deduction algorithm that use a variant of resource allocation, various allocation graph called the wait for graph. Here we have the diagrammatic representation for the wait for graph. Next one, deadlock recovery. In deadlock recovery, first point is process termination, that is about all the deadlock processes. Second one, about one deadlock processes at a time until the deadlock cycle is eliminated. Third one, after the each process is aborted, a deadlock deduction algorithm must be invoked to determine where any process is still deadlocked. Next one is resource presumption. presumption some resources from process and give these resources to other processes until the deadlock cycle is broken. Here we have the three types. That one, selecting a victim, rollback and starvation. First one, selecting a victim. Which resources and which processes are to be preempted. The next one, rollback. If we primitive a resource from process, it cannot continue with its normal execution. Third one, starvation. How can we guarantee the resource will not always be primitive from the other processes? Thank you.